This question has two parts. We will begin by sketching the feasible region and shading it in, but first we need some axes, so we'll do that. So we've chosen the scale fairly carefully so that we'll be able to draw on all our constraints. Now we're going to draw these as equalities. The easiest thing to do is find where each line intercepts the x-axis and the y-axis and just draw the line through those 2 points. So for the first one, 2y plus 3x equals 12. This will go through 6 on the y-axis and 4 on the x-axis. And we need to label it 2y plus 3x equals 12. Then we do the next one, y plus 4x equals 8. So this will go through 8 on the y-axis and 2 on the x-axis. And again, we label y plus 4x equals 8. This question has some nice symmetry. We have 4y plus x equals 8. So y equals 2 and x equals 8. 4y plus x equals 8. Now, remember which side of these lines we're staying on. If you're not sure, you can pick a point and see whether you are satisfying the constraint or not. It's fairly clear that because these are all greater than or equal to signs, we'll also have x and y greater than or equal to 0. Our feasible region is this area here, contained by all our lines. We can just shade it in nicely. And that's part A. Now for part B, we're going to draw some level sets. We'll do that in a different colour. To find a level set, we set z equal to some constant. So we'll begin with, say, z equals 0. That will give us the line y equals minus x. And we can draw that in straight through the origin. And we'll just label it with the z value. So this one is z equals 0. Now we can try z equals 2, and that will give us y equals 2 minus x. That's just as easy to draw. It's just parallel to the first line, just like that. Z equals 2. Now there's a pattern forming here. We can see where this is going. So we'll draw in a few more parallel lines. Just like this. We can label those. Z equals 4, Z equals 6, and Z equals 8. We're starting to get a bit crowded now, but we can still see what's going on. Now, we might want to draw just one more in to see really clearly. So this will be Z equals 5. Since we're minimizing Z, we want to move in this direction. And we will find the last remaining point in the feasible region, which falls between this line and this line, and that's this point here. Nice and clear. Now we can't immediately see what the coordinates are, so we'll need to see at what point this line and this line meet. So it's just a little bit of high school maths. 4y plus x equals 8 and 2y plus 3x equals 12. From this we can get x equals 8 minus 4y, and plugging that value into our equation here gives us 2y plus 3 times this, 8 minus 4y, is equal to 12. And then it's just a matter of rearranging to get a value for y. So 2y minus 12y is minus 10y, plus 24 equals 12. And moving things around, we get 12 equals 10y. Therefore, dividing both sides by 10, we get y equals 12 on 10, which is just 6 on 5. subbing that into our original thing, we'll see x equals 8 minus 24 on 5, which is equal to 16 on 5. Now, our question just asks for the corner where the optimal solution occurs, and that's what we found. We found the coordinates for it, so we have a final statement. The optimal solution occurs at 16 on 5, 6 on 5. And the question doesn't ask for it, but it's pretty easy to say what that solution is. We just substitute these values into the original objective function, and it's easy, we just add them together. So it's Z is equal to 22 on 5. Beautiful. Oh, there should be region up here.